Hello viewers, welcome to Math with Kantoma. In today's class, we'll continue and derive the half-angle formula of trigonometry. So last class, we derived the double angle, we derived the identity equations, we derive the double angle, and we derive the triple angle formulas. But today we are going to look at half angle formulas. How do we derive the half angle formulas? So now we are going to recall from the double angle formula where we derive the value for cos 2a as cos square a minus sine square a. We said this is the formula for double angle for cosine. So now we're going to use this formula to derive the half angle formulas for cosine and then for sine also. So now from this I can substitute the value of sine square a as, remember from first identity equation where we said sine square a plus cos square a is equal to 1 from identity equation 1, right? So now I can make sine square a the subject by saying sine square a is equal to 1 minus cos square a, right? So now substituting the value of sine square a in this double angle for cos 2a. So now by substitution we say cos 2a is now equal to, instead of sine square a, I will have cos square a minus this. So I'm going to open the bracket 1 minus cos square a. So now I'm going to open this bracket with respect to the negative sign here. So if I open the bracket, I will have cos 2a is now equal to cos square a minus 1 minus times minus is plus cos square a. So now I have cos square a and cos square a are uniform, so I can add these two together. Cos square a plus cos square a, I will have cos 2a now is equal to 2 cos square a minus 1. And again, I can make this the subject by taking this one to crosses the equality. So I will to say cos 2a, this is minus 1, when it crosses the equality it becomes plus 1, is equal to 2 cos square a. So therefore I can rearrange this by saying 2 cos square a is the same thing as cos 2a plus 1. So I'm looking for cos square a. Let me divide both sides by 2, divide this side by 2 also. So 2 go with 2. I'll be left with cos square a is equal to cos 2a plus 1 divided by 2. So this equation, let me say this is equation 1. This equation I'll be using to take the half angle formula. So next I'll do the same thing for sine. I can substitute the value of cos square a, relating it with the first identity equation. So now from first identity equation 1, let me say also cos 2a is equal to cos square a minus sine square a. But from equation 1, from identity equation 1, where we said sine square a plus cos square a is equal to 1. So now let me make cos square a the subject. So therefore cos square a is equal to 1 minus sine square a. So now I can substitute the value of cos square a here to be 1 minus sine square a. So therefore I said cos 2a now is equal to, instead of cos square a I will write this 1 minus sine square a, then minus sine square a also. So I can still simplify this. Cos 2a is now equal to minus sine square a minus sine square a. I have minus 2 sine square a. So now let me make sine square a the subject. So when sine square a crosses the equality, it becomes positive because this is negative. This one also crosses the equality. Or if I like, I can do it this way. let cos minus 2 sine square a crosses the equality. I have cos 2a plus, when it crosses the equality, it becomes plus 2 sine square a is equal to 1. So again, let me take this one to crosses the equality here. So leaving this alone, 2 sine square a is equal to 1 minus this now, because this is positive. On crossing the equality, it becomes negative. We have minus cos 2a. So I'm looking for sine square a. Let me divide both sides by 2. This by 2 also. This go with this. So therefore, sine square a is equal to 1 minus cos 2a all over 2. So let's say this is equation 2. So now, these are the two equations I'll be using to find the half angle formula for cos A and sine A. But we will have to derive the formula for that of the tangent. So now let's see. For the tangent, we'll say tan square A is the same thing as sine square A over cos square A. Right? By definition, we say tan is sine theta over cos theta in our last class. So we are donating theta by A. So we have tan A is equal to sine A over cos A. And also tan square A is the same thing as sine square A over cos square A. So now, the value for sine square A here, we said is this function. And the value for cos square A is also this function. So I'll be substituting these two functions into the equation here. So therefore, substituting for sine square A and also cos square A will now yield this value. Tan square A is equal to, instead of sine square A, I have this function, which is 1 minus cos 2A. Divide this by 2, and also I have another division sign for cos square A. Now cos square A is this function also, which is cos 2A plus 1. Divide this by 2 also. So from here, you believe with me that these two will cancel these two, or if you like, if it's confusing, then I can write this as 1 minus cos 2A divided by 2, divide this by cos 2A plus 1 also over 2. So now this division can change into multiplication by taking the reciprocal of this very fraction. So this will now be multiplication, and this will now come down while this will go up. So I have 2 over cos 2A plus 1. So from here, these two can cancel these two. So you see it's still the same thing here, right? So next, I will multiply this numerator by numerator and denominator by denominator. So what I'll be left with, tan square A is equal to 1 minus cos 2A. 1 minus cos 2A. 1 minus cos 2A times 1 is 1 minus cos 2A divided by 1 times cos 2A. We have cos 2A plus 1. So now this is equation 3. So now these are the three equations I'll be using to derive the half angle formulas. So now let's look at the half angle formulas. So now let me not delete this. So for the half angle formulas, we are going to start by assumption. We say let this A we are dealing with be equals to alpha over 2. Meaning it is half of an angle. The angle alpha here is an angle of inclination. So now, let A be equal to half alpha over 2. So wherever we see A, we are going to substitute it by half alpha over 2. Anywhere you see A. So now, starting from the first equation 1, taking the first equation 1, where we say cos square A is equal to cos 2A plus 1 divided by 2. So now I said we are going to start by assumption by letting A to be equal to alpha over 2. So wherever you see A, substitute it by alpha over 2. So now by substitution, we have cos square alpha over 2 is equal to cos 2. Instead of A, I have alpha over 2 plus 1 divided by 2. Right? So from here, these two will go with these two. So we'll be left with cos square alpha over 2 is equal to cos alpha plus 1, divide this by 2. So what we are looking for is cos alpha, cos of the half angle, cos alpha over 2, not cos square alpha over 2. So I will have to multiply 2 by 1 over 2. The power, multiply the power by 1 over 2, or take square root of both sides. So if we take square root of both sides. So now, when we take square root of both sides, let me write this one somewhere, because we'll need this. We are going to need this tan alpha over tan square a is equal to 1 minus cos 2a all over 1 plus cos 2a. Either cos 2a plus 1 or 1 plus cos 2a is still the same thing. So we'll be needing this equation also. So next, if I take square root of both sides, I will have this as cos square alpha over 2 raised to the power of 1 over 2 is equal to plus or minus square root of cos alpha plus 1 all over 2. The reason why we are taking plus or minus, the value of alpha depends on the quadrant it lies. For each quadrant, the value of sine, cosine, and the tangent are going to be. So we need to derive what value of sine or what value of cosine is on the quadrant, on each of the quadrants. For example, this is a quadrant. These are our quadrant. So let's say this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So now on this quadrant, I have, this is my y-axis, this is my x-axis, this is the negative x-axis, and this is also the positive. Let me draw it somewhere here so that it will not be confusing. I can wipe this. So now the quadrant is this. This is the y-axis, this is the x-axis, this is negative x-axis, and this is also negative y-axis. So now we say this is the first quadrant, this is the second quadrant, this is the third quadrant, and then this is the fourth quadrant. So now in the first quadrant, if we plot our right angle triangle on the first quadrant, this is my right angle triangle, this is the angle of inclination, alpha. So now this side, from here to here, the distance, let me call it A, and the distance from here to here is on the positive x-axis. Likewise, the distance from here to here on the y-axis is also positive. So let's say this is B, right? The value from here to here, that's the coordinate. If we take the two coordinates, is going to be a positive value. So I just make an assumption by saying this is A value, this is B value. What we should take note is the positive value on this axis. A is positive on the x-axis here. B is also positive on the y-axis here. Then C is now my slope, the slope of this very triangle. So now by definition, if I take sine of this angle, meaning sine theta here, is going to be opposite over hypotenuse by definition using SOHCAHTOA. Opposite is B, hypotenuse is C, and B is positive, C is also positive. So now any number we divide here is going to give you a positive value. So we say sine theta on this quadrant is positive. Then next we look at cos theta. Cos theta on the first quadrant by definition is CA. Cos theta, cos of this angle is adjacent over hypotenuse, and our adjacent here is A, hypotenuse is C. So A over C is also positive because A is positive, B is positive, C is positive. So now A over C is going to give us a positive value. So therefore cos of this angle on the first quadrant is also positive. So now taking the tan of this angle, tan theta. What is tan theta? Tan theta is two are opposite over adjacent, B over A. So now b over a is also positive because b is positive, a is positive. So whatever value you have and you divide, then tan theta is going to be positive on this quadrant. So in the first quadrant, we said all angles or all the signs are positive. So we denote it by a, meaning sin theta is positive, cos theta is positive, tan theta is also positive. So now considering the second quadrant, draw a right angle triangle on the second quadrant. The value here is my slope, which is always positive, c. So the value here from this point to this point is on the negative x-axis, so definitely is going to be a negative a. While the value here from here to here on the y-axis is on the positive y-axis, so it's going to be positive b. So only a is negative on this axis. So now if we find sine of these angles, angle of inclination here theta, sin theta here is going to be opposite is b over hypotenuse is c, so we have b over c. So b is positive, c is positive, so whatever value we have, everything will be positive. So sin theta is positive on this quadrant. Then cos theta here, cos theta on the second quadrant, cos theta we said is adjacent over hypotenuse, which is minus a over c. So now the negative value is going to affect every other value that is here, because when you divide any value, you are still going to have a negative value here. So now cos theta is negative on this quadrant. The next is tan theta. Tan of this angle theta, tan theta is 2r, opposite over adjacent. Opposite is b and adjacent is minus a. So whatever value you divide, you are still going to have a negative value because of the adjacent, which is negative a. So now tangent on this quadrant is also negative. So in this second quadrant, we said only sine is positive, so we denote this by s, meaning only sine is positive on the second quadrant. So now taking the third quadrant, this is my third quadrant. So now on the third quadrant, the distance from here to here is also negative a because it's on the negative axis, negative x-axis, while the distance from here to here is on this y-axis and is also negative b. So it's also a negative value, while the slope is also positive, which is c. So now to find the sine of this angle of inclination here, theta, sin theta now on the third quadrant is equal to opposite minus b over hypotenuse. Hypotenuse is c. So whatever value you have on this quadrant, sine must be negative because of the negative value b. And also cos theta on this very axis, cos theta is adjacent to this angle is minus a over hypotenuse. Hypotenuse is c. So now minus a over c is definitely going to give us a negative value. So therefore cos theta on this quadrant, on the third quadrant, is also negative. Then now the tangent on this quadrant, meaning tan theta. Tan theta on this quadrant, 2r, is opposite to this angle, which is minus b, over adjacent, which is minus a. So minus will go with minus, leaving only b over a. So b over a is positive. So therefore, tan theta on this third quadrant is going to be positive. So we donate this quadrant by t, meaning only tan theta, only tangent is positive on this quadrant. Then now we'll take the fourth quadrant. Consider this to be our right angle triangle. We have our slope c. We have this distance from here to here is a on the positive x-axis. The distance from here to here is plotted on this y-axis and is negative, so it's going to give us negative b. So the angle of inclination is here, theta. So now if this is the angle of inclination theta, then what is the sine of this angle? Meaning sin theta on this quadrant is going to be opposite over hypotenuse, meaning minus b over c. So whatever value you have, then definitely sine is negative. Then cos theta on the fourth quadrant is going to give us which is adjacent, which is a over hypotenuse, and is c. So a over c is positive. All the signs are positive. So now cos theta on this quadrant is positive. And the last one, tan theta. And then what is tan theta? Tan of this angle is going to be opposite, which is minus b over hypotenuse, and is c. So minus b over c. So the unit here is negative. So whatever value we have is going to be a negative value, is going to affect the sign. So therefore tan theta on this quadrant is going to give us a negative value. So we said on this quadrant only cos theta is positive. So we donate this quadrant by c. So we can donate all the quadrant with a simple logic by saying this is cast, starting from the fourth quadrant. Cast, only cosine is positive on the fourth. On the first, only all the angles are positive. On the second, only sine is positive. On the third, only tangent is positive. So this is how we donate the values of the sine, or the sines of each of the angles of these three angles on the quadrant. So now coming back to our problem, we said cos square theta, cos square alpha over 2 is equal to plus or minus cos alpha plus 1 over 2. The reason why we take the square root is to eliminate this power here. So now this power will go with these two. So we'll be left with cos alpha over 2 is now equal to plus or minus square root of cos alpha plus 1 all over 2. So now this is the first formula for half angle formula on cosine. So next we'll be deriving is the sine angle formula for half angle formula. Next is this angle. So now the half angle for sine square A is equal to 1 minus cos 2A all over 2. So now, using this formula, we're going to derive the half angle formula for sine. So we start by assumption also. We said, let A be equal to alpha over 2. Our angle here now is alpha over 2, meaning half of the angle, half of this A, I can let it be A over 2. It's still the same thing. So I'm using another value so that we will not be confused. So now, substituting the value of alpha, A to be alpha over 2, we have sine square alpha over 2 is equal to 1 minus cos 2 alpha over 2, divide this by 2. So now I'm going to find sine, not sine square. So I must eliminate this power 2. So now we'll take square root of both sides. So we're going to have, by taking square root of both sides, I will have sine alpha over 2. The power here will go is equal to plus or minus square root of 1 minus cos 2 minus cos 2 alpha over 2 divided by 2. But here, these two will go with these two. So therefore, I will be left with sine alpha over 2 is equal to plus or minus square root of 1 minus cos alpha over 2. So now this is the second equation for half angle formula with respect to sine alpha over 2. So next we'll be deriving is the half angle formula for the tangent. Tan square A, we donate the tan square A by 1 minus cos 2A all over 1 plus cos 2A. So now this is the formula. So we'll be using this to derive the tan of the half angle. So now we said let also A be equal to alpha over 2. So now we're going to substitute the value of A to be alpha over 2 in this equation. So the equation will now becomes tan square, instead of A I have alpha over 2 is equal to 1 minus cos 2 times alpha over 2 all divided by 1 plus cos 2 times alpha over 2. So these two will go with these two. These two will also cancel these two. So now we'll be left with, I can take square root of both sides to remove the power here. So I will be left with tan alpha over 2 is equal to plus or minus square root of 1 minus cos alpha divided by 1 plus cos alpha. So this is equation 3. So now these are the 3 half angle formulas, and we have successfully proved or derived the 3 half angle formula with respect to sine, cosine, and the tangent. And that is it for today. If you are visiting the channel for the first time, kindly subscribe, like our page, and hit on the notification bell. Thank you.